talk about in this module has to do with what happens when air in the sky becomes saturated, when moisture condenses. Well, we get those beautiful things called clouds. And so we're going to talk about in this lecture our different types of clouds, and then we're going to talk about something that's very common here in the Bay Area, fog. So with that said, first off, meteorologists kind of get a bad reputation in that a lot of people think that we just look at clouds. Now, because we're in the fourth module and we've already talked about things like the structure and composition of the atmosphere, we've talked about radiation, conduction, convection, we've talked about all that stuff so far this quarter. I kind of hope that you see that there's a lot more to meteorology than just clouds, but let's take a look at some clouds. So, first off, what is a cloud? Well, clouds form when there's a visible collection of water droplets. So, what happens is as air becomes saturated, more and more moisture begins to condense into liquid water. Now, initially, these water droplets that form are usually not visible to the naked eye. However, as more moisture condenses and as they get bigger and bigger, they become visible to the naked eye. And believe it or not, the average water droplet that forms a cloud, or that forms in a cloud, is typically 1 million times smaller than a typical rain droplet. So it takes 1 million cloud droplets to form one rain droplet, or to form one raindrop. Now, with that said, we're not going to talk about raindrops right now. Those actually don't form via condensation. They form via something else. We'll talk about that in the next module. But today, we're going to talk about clouds and how they form. So, clouds take on many forms and at many different altitudes. We have some clouds that are low to the ground, like over here. This image right here represents one of those types of clouds. This is called a stratus cloud. We have other clouds that are very high in the sky and they take on a feathery, wispy form. These are called cirrus clouds. And then we also have our standard puffy cotton cloud. Those are called cumulus cloud, or cumulus clouds. And each one of these clouds actually brings with it a different type of weather. So first off, how do we classify clouds? I just showed you 3 different clouds. Well, cloud classification didn't really occur until the early 1800s, when a scientist by the name of Luke Howard developed the first widely used classification system. And it's one that we still use today. And it split clouds up into 4 main groups: Stratus, Cumulus, Cirrus, and Nimbus. A stratus cloud is a layered cloud. It's a cloud that pretty much covers the entire sky, and it's like a sheet almost. It's like a sheet that covers the entire sky. So if you ever look outside and the sky is completely cloudy, it looks gray, you can't really pick out individual clouds, those are most likely stratus clouds. The second type of cloud, and this is the type of cloud, if I asked you to draw a cloud, you would probably draw one of these. They are those puffy, white, cotton ball type clouds. Those are called cumulus clouds. And again, yeah, those look like a mass of cotton balls. They're puffy. If you look higher in the sky, and you notice that some clouds have a wispy, almost like a pulled cotton ball-like structure to them, almost a feather-like structure, those are called cirrus clouds. And then the fourth type of cloud that Howard's classification system used or included were clouds that created rain, clouds that where the droplets were large enough inside to begin falling to the ground. Those are called Nimbus clouds. Now, this does a really good job actually splitting up different clouds into different types of classifications. Right here, we have a nimbus cloud that looks really dark. It looks like rain could fall out of it at any moment. And one of the reasons why it looks so dark is because there are bigger droplets in this cloud that do a really good job of absorbing sunlight. And since they absorb that sunlight, they take on a dark color. Similar to like if you have a dark t-shirt and it absorbs a lot of sunlight, it gets hot, but it looks dark. So the same thing's happening here. This is what's called a nimbostratus cloud. If you notice, it looks like one giant cloud. You can pick out a few little individual pieces of it, but it's one giant layered cloud. Here's a good old cumulus cloud. And again, these look like those cotton ball type of clouds that you would probably draw. Here are some cirrus clouds. And then here's another nimbus cloud. Right here you can actually see the rain falling out of the cloud. This area of wispiness, this is actually rain falling out of the cloud. Now, this classification system is very useful. However, we have discovered many more clouds since the original Howard's classification system was developed. And since we found new clouds, we have modified the system. In 1887, not that the date is super important, but I just want you to know, in the late 1800s, two scientists, Ralph Abercrombie, I don't know if he's related to Abercrombie and Fitch, and Hugo Hildenbrandsen, try saying that name 3 times fast, they made modifications to Howard's system in order to expand it. So basically what they did, rather than poo-pooing his system and throwing it out, they took it and they improved it. Just like what scientists do. What we do is we take things, we figure out what's missing, and we improve it. They took the ball and they ran with it. And so the modified Howard system is the system that we use today. And this system categorizes 10 different cloud formations, so 10 different types of clouds, into 4 groups based on the cloud's altitude. Let's look at them. So here is the overall modified Howard's classification system. And there are 4 main groups. There are low clouds. These are clouds that form below 6,500 feet. Middle clouds. These are clouds that form between 6,500 and 23,000 feet. And then high clouds. These are clouds that form above 23,000 feet. One of the things that you should know is typically low clouds are given the prefix strato. Middle clouds are given the prefix alto, and high clouds are given the prefix cirro. Now there is one exception to this, and that exception happens over here. Over here, we have what are called vertical development clouds. This is the 4th category. These are clouds that can actually span across multiple layers, multiple heights in the troposphere. And there are 2 types. There's cumulus and cumulonimbus. And so these have cumulo to them. So again, strato, low clouds, alto, mid clouds, cirro, high clouds, cumulo, clouds with vertical development. And these types of clouds form from rising air. So air is rising. As it rises, it expands, it cools and condenses and creates clouds. Now what you'll actually notice is there are different types of cumuloclouds. These are what are called cumuliform clouds. There are different types. Some types don't really grow too big. They're just what are called cumulus clouds. The reason why this happens is because the atmosphere is stable above these clouds. And since it's stable, the air can't continue to rise. We're going to talk about that more in the next module. However, if the atmosphere is very unstable, that air is allowed to continue to rise, and the cumulus cloud grows taller and taller and taller until it eventually becomes what's called a cumulonimbus cloud. This is a cumulus cloud that is capable of producing thunderstorms. We'll talk more about that in the next module. So low clouds are just clouds that occupy the first 6,500 feet above the surface. And they are affixed with the prefix strato. So stratus clouds, stratocumulus clouds, and nimbostratus clouds. And because these clouds occupy the lower portion of the atmosphere, they're almost always water droplets. They're almost entirely made out of water droplets. So again, here's an image of a nimbostratus cloud. Here are some stratocumulus clouds. These still kind of have that sheet-like feature to them. The only difference is they're now broken up into individual puffs rather than one continuous sheet. Here's a nimbostratus cloud, rain's falling out of it. Going higher, going above 6,500 feet, you get into the mid-levels of the atmosphere. And these represent what are called middle-level clouds. There's some different heights here. If you are in the middle latitudes where we live, the top of this layer is 23,000 feet. If you're in the tropics, it's 26,000 feet. If you're in the polar latitudes, it's 13,000 feet. And the reason why this happens is in the tropics, the air is really warm. And so the atmosphere is thicker in the tropics. Whereas in the polar latitudes, the atmosphere is a lot shorter. It's a lot thinner. It's not nearly as thick. It's not nearly as tall in the polar latitudes. You don't have to really worry about that. I just want you to know that the middle level represents the middle portion of the troposphere. And here is where alto clouds form. And these clouds are affixed with the prefix alto. And there are two types, altocumulus and altostratus. Altocumulus and altostratus. Altocumulus clouds are mid-clouds with really small puffs. They're individually visible, but they're small. And then altostratus, that's just a sheet of mid-level clouds. Now usually, once we get up into the middle levels, these clouds aren't very thick. And in many cases, sunlight can still shine through. And in fact, in the case of an altostratus cloud, the sun may even still be visible. So here are some altocumulus clouds. And again, they pretty much just look like little round balls of clouds. They're a lot smaller than stratocumulus clouds, and that's how we know that they're altocumulus. Those puffs look smaller. And then here's an altostratus cloud. I lied, sorry, altostratus cloud. It's just a long gray layer, and if you notice, you can still see the sun, but it's a lot dimmer. You can even look at it with the naked eye, not that I would suggest that you do that. It's never good to look directly at the sun, even during an eclipse. Bad idea. But still, you can even still see the sun through them. Finally, getting up into the top of the troposphere, we get into the high levels of the atmosphere, and these represent the highest altitudes in the troposphere. In the high levels, there are two key features of these clouds. The two key features come from the fact that, one, the temperatures up there are extremely cold. So these types of clouds are entirely made of ice, almost exclusively made of ice. The other thing is that in the upper layers of the atmosphere, the winds are a lot stronger because there's no friction slowing them down. As a result, these clouds often look like cotton that's been pulled apart. Why? Because the wind is pulling apart these clouds into little wispy, feathery-like pieces. There are three types of high-level clouds: cirrus clouds, cirrocumulus clouds, and cirrostratus clouds. And if you notice, all three of these types of clouds have been prefixed with cirro. Cirrus clouds are the ones that almost look like feathers. Cirrocumulus clouds are a very, very, very thin sheet. You can still see the sun perfectly fine through them, but you can also see that there's just a tiny, like milky type of layer. It's almost invisible, but it's there. And this actually creates what looks like the scale of a mackerel. We often call this mackerel sky. And then finally, cirrostratus clouds are thin clouds that are almost perfectly transparent. You can clearly see the sun through them, but one interesting thing that happens is in cirrostratus clouds, you can also see a halo forming around the sun. So here are some cirrus clouds. Again, they look like feathers. They look like cotton that's been pulled apart. Here's some cirrocumulus clouds. And these are clouds that have an almost like fish scale-like look to them, hence the term mackerel sky. And here is a cirrostratus cloud. And again, the sun is perfectly visible around these, but because there is water up here, and because there are ice crystals, you can actually see a halo around the sun. The last type of cloud I'm going to talk about before I get into fog are cumuliform clouds. These are that fourth category. These are clouds that can span multiple layers. They can span the lower troposphere, the middle troposphere, and the top troposphere. And these look like heaped cotton balls. These form when air is allowed to rise. And if the atmosphere is unstable, this air can actually rise very high. And the higher it gets, the taller these clouds become. There are two main types of clouds: cumulus clouds and cumulonimbus clouds. Cumulus clouds, again, are just those textbook white puffy clouds. And those could be broken up into three categories: cumulus humulus, cumulus fractus, and cumulus congestus. Cumulus humulus are those fair weather puffy clouds. They don't get really tall, but there's a little instability in the atmosphere, so the air is able to rise a little bit. But again, it's not allowed to really get too tall. These are also referred to as fair weather cumulus clouds. We see these outside when the weather's very fair, very nice. Cumulus fractus clouds, these look like broken clouds. And then the third type of cumulus clouds is what's called cumulus congestus clouds. These are actually the predecessor to cumulonimbus clouds. In this case, the air is unstable and the cloud is becoming taller and taller and taller. The difference between a cumulus congestus cloud and a cumulonimbus cloud has to do with the fact that in the case of a cumulus congestus cloud, the top of the cloud does not reach the tropopause. In this case, it just looks like a heaped pile of cotton. However, in the case of a cumulonimbus cloud, the top of the cloud actually reaches the tropopause, and the cloud can't rise anymore. So rather than going straight up, it begins to fan out, and I'll actually use my little cursor here to show this. Rather than going straight up, it fans outward, like so, creating what looks like an anvil shape. So if you've ever seen Looney Tunes, I know that that's old school, but if you've ever seen Looney Tunes before, and Wile E. Coyote has the anvil, this is what that looks like. The top looks like an anvil. These are also referred to as anvil heads, pretty often. So here's some fair weather cumulus, some cumulus humulus, just puffy white balls of clouds. Here's some cumulus fractus. These are broken cumulus clouds. Here's a cumulus congestus cloud. So now this is a cloud that's growing taller, and it looks like this large heaped pile of cotton. And then here's a cumulonimbus cloud. In this case, right here's the tropopause, and the air that was rising reached the tropopause and had to fan out. What actually may happen, though, is every so often, this air is rising so fast that it can actually blow beyond the tropopause and into the stratosphere. And it creates this little puffy top to it called an overshooting top. This occurs whenever you have severe thunderstorms. We'll talk more about that when we talk about extreme weather.